very much naturally a loud speaker, so if anybody decides that they can't hear me, which I can't possibly imagine is true, let me know and I'll start using the mic. I'm really excited to be able to be here and talk to you guys tonight. I'm going to talk about one approach, at least, to large-scale ETL processing. Again, my name is Eric Sammer. I'm an engineering manager at Cloudera. I've been with Cloudera for about 3 years, which in Cloudera dog years is a really long time. I manage 2 different teams at Cloudera, one of which does what we call partner engineering, which is integration with all of Cloudera's partners like Informatica, SyncSort, Oracle, Dell, HP, and so on and so forth, as well as BI vendors. And then the other team is a new team that we just built out that's actually building a software development kit for building data processing applications and systems on top of what we would call the platform, which in our case is Hadoop, MapReduce, Hive, Pig, HBase, Flume, Scoop, Uzi, all these other systems. I'll tell you a little bit more about that a little bit later, but for now I just want to kind of dive into things. So I always like to say that ETL is like rest or disaster recovery. And what I mean by that is that everybody defines it differently, and everybody loves to fight about their favorite definition of what it actually means. And then you get into the semantics of, no, that's ELT, not ETL, and all that other good stuff. I like to throw up my hands and abstain from those discussions in general. But I kind of like to think about ETL or data processing or data engineering as more of a problem solution space than any one specific thing. It's a practice, it's a discipline, and it's not a particular piece of technology. It turns out that it's really hard to generalize ETL or data processing or data engineering without being lossy in some way. And what I mean by that is a lot of the general purpose systems out there in the wild, and I've used all of them at some point or another. So for instance, systems like Spring Batch or the commercial ETL tools, maybe to a lesser extent, but a lot of the open source ones that I think you can go and look at today kind of go one or two ways when they talk about ETL or building data processing pipelines. Either they're hyper generic, in that they basically say, give me a blob of code with a main function and I will call it when it's time to call it, and I'll set all kinds of environment variables, and pass in the information you need, and you sort of run in my little bubble. Or they're hyper specific, and they say, write a function that operates on a single record, and I will do all of the other stuff to make sure that that gets called in the right order, so that, like, Spring Batch winds up looking very much like that. It's really hard, and it's not that either one of these are bad. It's not that the commercial ETL tooling is bad or the traditional commercial ETL tooling is bad. It's not that Spring Batch is bad. It's just that it's a hard problem to generalize, just generally. And people at SyncSort, for instance, spend an awful lot of time thinking about how to do this and make it efficient and not make it either overly generic or overly specific, but it's still a problem. But worst of all, and this is the thing that kills probably all of the people who cut your paycheck, is that at face value, it looks really simple. You get a file bunch of records, you need to tear them apart and build another file with a bunch of records. No problem, right? You know, turns out it's really complicated in practice because of all the other stuff that happens around ETL jobs. So really, what makes ETL hard? And again, this is my highly opinionated talk, so these are what things I think makes ETL hard. It's not hard anymore because the ability to perform some function on record A and produce record B. That's the thing that Hadoop, for instance, is really, really good at. You know, it gives you all the infrastructure to be able to do function of A producing B at scale. That's kind of the only thing it does, but that's the thing that it does really well. I think data integration or ingestion in general is a hard problem. And it's really easy when you have a single source, when you have a web server or 5 or 10 or 5,000 that are all spitting out logs and all need to go someplace. Fine. That's kind of easy. I'm talking about people that have that, and then somebody comes along and goes, well, you know, we also use Google Analytics. Yeah, and we also have this legacy process for core metrics, but it only applies to this one site over here, and it's a microsite, and that site's kind of going to go away and come back, and we're going to rename it, and it's going to go from this to that, and we're going to redirect all the URLs. And oh yeah, we also want to bring in email marketing data, or we're partnering with Experian to do data set enrichment. And like, you kind of go like, wait, can't I just get like the web server logs in and in the right format before we start with all that nonsense? So that's sort of what I mean by data integration. Data organization, management, and monitoring. And now I'm really doing it not justice by referring to it as just 3 words with commas in between. It's really all of the infrastructure about building these processing pipelines and being able to say all data from all ad servers has arrived for the last hour. Turns out that's actually a hard problem at some level. Knowing that you have all events, that a web server hasn't died or didn't send that one file, or accounting for bad records, or all of these other things that wind up happening. So you get into things like data quality monitoring and all this other infrastructure around it. So when people say like, yeah, you know, my ETL stuff, it's a handful of Python scripts, why so hard? And I kind of go like, you know, here's why hard. And I walk over to a web server and I pull out an Ethernet cable, and like they have no idea that that happened. So, you know, weird things start happening in real large-scale ETL. And I'm talking about large-scale. I'm not talking about I have one process, it runs hourly, and I can stare at cron logs and find out if it ran or not. I'm talking about large-scale ETL, hundreds of thousands of different data sources, or even just hundreds of data sources all coming together. Process orchestration and scheduling as 2 separate disciplines. Process orchestration being what Pete referred to before, things like managing process A produces data that is required by B, which produces data that's required by C, and then C and D can run in parallel, and then I want to wait until they converge and join again. There are open source tooling, things like Uzi, that do this today, but it's still a really hard problem dealing with, you know, synchronization and failures within those pipelines and things like that. And scheduling, man, if general purpose scheduling as a service in the data center is not a really hard problem. And it turns out that most people either punt and go, well, I just have 5,000 entries in my cron tab for each user, or they kind of build embedded things like courts into a bunch of different processes. I know Airbnb recently announced Kronos, which is an open source thing that's kind of like cron on steroids and with some additional bells and whistles. That's a little bit closer to what I'm talking about. And for you folks that are in like the enterprise space, who work in cubes and things like that, those folks are familiar with systems like UC4, which is a very, very large enterprise class bulletproof scheduling, distributed scheduling system. Distributed meaning that I create and manage jobs and processes in one place, and in that central place I say this process runs on that machine or the other machine if it's not available, you know, once an hour, and I need you to tell me if it's, you know, out, if it's running slow and it's not going to make its SLA and all that other stuff. General platform accessibility. And by accessibility, what I mean is the ability for a new developer 5 days in to come in and either modify or add a process. For many people, ETL is like, it's, you know, building your own ETL platform is like a rite of passage. If you're a Ruby developer, like Hello World is like building your own blog. If you're a data engineering person, Hello World is like building your own ETL platform. And everybody kind of the people I poll, everybody has built one. They all agree that they don't like any of the ones that already exist, but they would never package and sell you theirs. So they kind of hate that one too. It's really interesting, but at the end of the day, it's really about how this all fits together. That's really the tricky part. So how many people in the room are familiar with Hadoop today? Okay, so Hadoop is made up of 2 giant pieces. I'm not going to go into details. There's HDFS, the distributed file system. It's a big bit bucket, and it looks like a file system. and MapReduce, which is specifically geared towards batch-oriented data processing at scale. So the ability to perform that function of A producing record B with all of the, well, most of the necessary scaffolding around it. The Hadoop ecosystem supplies a bunch of additional infrastructure that, most people want. So for instance, things like higher level languages and abstractions on top of MapReduce, because all it takes is you to implement join in low level Java MapReduce once before you never ever want to do it again. It's really terrible. So some of those higher level languages are things like Hive and Pig and Cascading and Crunch. And again, this is a place where we see a lot of the traditional ETL vendors, again, people like SyncSort, people like Informatica, Pentaho, building an integration to push down to MapReduce and sort of offload the mechanics of executing that function and things like that, of course with their own specialization on top of it. But this is one place we see a lot of integration. File, relational, and streaming data integration. Those are the three main buckets that I tend to think about. You have files that arrive as files, and they need to be moved around as files. The order of the records is important, and the fact that they are a batch grouped together is also important. Streaming data ingestion or integration, on the other hand, is where order of those events is not important, and the fact that they are in files together is not important. It's a pragmatic way of moving them. And that's where systems like Flume and Kafka and Scribe do very, very well in moving those events in high bandwidth. Scoop is one open source project that basically lets you point at relational database tables or even a full database and say, all those tables, put them in HDFS or put them in HBase. It's very good at exactly that and the inverse, sending them the opposite direction, but that's pretty much all it does. There are tons of other things as well. Process orchestration and scheduling. This is where we have systems I mentioned before. We have things like Uzi. Azkaban is another popular one. Kronos, I don't know if it actually has the orchestration side, but it definitely has the scheduling side. There are plenty of other systems out there like that. One place that we don't actually talk very much about, but libraries for parsing and text extraction. I really think that if you're writing regexes day in and day out, that gets old really, really fast, and you kind of need a better solution over time. The ability to compose regular expressions or compose parsers, even more so than just regular expressions. So there's Apache Tika that is very, very good at doing things like taking a PDF doc or an HTML doc and knowing how to tear it apart into individual features, but not so much on the individual record parsing. There are libraries like Grok, which is part of Logstash, that is very good at taking named regular expressions and tearing things apart. I'm always curious to hear what other people use here, because I don't have a good 3 bullet point list here or a 3 item list. These days, low latency SQL engines on top of Hadoop are all the rage, and everybody's got one, including Cloudera. So ours is called Impala, and it's a traditional MPP style query engine. Very much follows the Dremel, Google Dremel / Google F1. In fact, the guy who built F1 works at Cloudera and is the tech lead on Impala. So Impala doesn't use MapReduce. It's open source, and you get to run low latency SQL queries. And the nice thing about Impala is that it has no file format per se. So you can map Impala tables over things like text files or protobuf files, or actually Avro files, and things like that, and it will do the parsing on the fly while it's querying records. So I guess at a high level, and when I kind of zoom out a couple of levels and I look at the problem, I kind of said well really the question is, how do you scale ETL? How do you go from having one Python script to having hundreds of thousands of moving parts in this big distributed system, which is effectively what ETL is. It's distributed systems with a strong bent towards data integration. I mean, that's really what it is. So to truly scale ETL, you do need to separate the infrastructure from the processes. And the infrastructure are things like retry semantics and monitoring and enqueuing and dequeuing and all of the other stuff around it. The processes are job 17 that's responsible for web sessionization and things like that. But you also need to make it a macro level service inside the data center. And by macro level service, I mean it's a service composed of many smaller services. And those smaller services of ETL are things like a process repository. Once you start getting big enough, you need a way, a standard way, of deploying individual data processing jobs or pipelines or whatever you decide to call them, and a way of executing them within that repository, versioning them within that repository. You need centralized metadata. You really need centralized metadata. The notion that how to parse a web record or event being hard-coded and being split on tabs and then index 17 positions into the array to get the user agent, that doesn't fly at scale. You really need metadata-driven processes. You need centralized scheduling, and you need scheduling separate from process orchestration. You need a system that can generate, it's 12 o'clock onto a pub sub, broker system that anything that cares about doing something at 12 o'clock can listen to, wake up, and react to. But those are separate systems. You then need process orchestration so that when you get that pulse, you know it's time to fire off a workflow and to step through that state machine. And you definitely need integration adapters or channels. And this is where systems like SyncSort and Informatica have a lot of experience about creating pre-approved connections to a relational database and then being able to grant access to some group of developers to that channel, so that you can actually create a set of connections and be able to grant privileges or revoke privileges to those adapters or channels. And the adapter side is really a system or a chunk of code that knows how to grab files from FTP or files from SFTP or SSH or files from a web service. You need adapters for all these different transports. You absolutely cannot survive without both service and process level instrumentation and metric collection. If you can't tell me how long it takes to process an hour's worth of sessionized log data, then you don't know what happens when the business guys run a campaign that doubles traffic, right? And if you don't know how many records per second you can handle, then you don't know how much hardware to buy. And you don't know what you're actually doing in production. So if you don't have this information and it's not centrally collected and available and on a dashboard that you can leave open all day, you're going to be in for some trouble. And the last one I like to throw around, which I think is, a lot of people think is a nice to have, but I think it's a hard requirement, is policy-based data management. And by this, what I mean, and this gets back to separating infrastructure from jobs or processes, policy-based data management to me means that on a named data set, like sessionized log data, I can attach a policy that says retain 365 partitions of data. If I add a 356th, lop off the oldest one, right? That shouldn't be something that's encoded into each individual job, because each developer will get it wrong in a slightly new and interesting way. I say this from experience. And I'm not talking about junior developers, I'm talking about when I get it wrong. So I really think that policy-based data management is also things like your data pipeline monitoring folks, and that might also be you who develops it, should be able to say, we're running low on disk space. I want to store all data in the most recent 7 partitions in Snappy, and I want you to compress everything older than that in gzip. That's a policy decision. That's not a code thing where you're messing around with IO streams decision. That's something that you should set and tag on a data set and be done with. And if you have the right infrastructure, you can do that. So that's really pie in the sky, and no one has all of those things. That's my wish list, if anybody's thinking of getting me something for Christmas. So what do we have today? Well, at the core, the nucleus, we have HDFS and MapReduce. These are building blocks. They are not a complete ETL system. And I work for Cloudera. Hadoop is not a complete ETL system. It is the execution engine and the storage for data. That's all it is. You really need all this other stuff around it. We have systems like Flume. We talked earlier about Kafka for streaming event data ingestion. Again, if you're on the enterprise side, Oracle Golden Gate, Informatica Power Exchange, I don't know the SyncSort stuff all that well, but things like that. Scoop, if you don't have something out of the box, it's a great place to start. Batch exchange of relational database tables with very, very basic change data capture, right? Grab me all records in table A that have been modified in the last, or since the last time I ran. And that's what I mean by change data capture. Again, the enterprise folks know what I'm talking about when I say that. And Scoop also, like I said, does the opposite. You can take a data set in HDFS or an HBase table or a Hive table, which is really just a data set in HDFS, and you can materialize it in a relational database as a table. Again, Uzi, and these are things that I work most frequently with. This is just kind of my list. You'll be able to find other open source projects, and I'm very bent towards the open source side here for fear of accidentally plugging the wrong partner or something like that. But Uzi gives you process orchestration. It's basically like, I almost hesitate to bring it up. It's been 10 years since anybody really talked about it. But BPM or business process management. There's a bunch of people going, oh, don't mention BPM. Well, yeah, Uzi's kind of like a BPM light. For those of you who have no idea what I'm talking about, you're in good luck. And you're probably under the age of 35. And again, Uzi gives you basic scheduling. It's basically got cron cooked into it, or Quartz cooked into it. If you don't know Quartz, it's actually a really, really nice Java library that does really nice scheduling and firing of events and stuff. And some people have asked me, like, where do you think like a low latency SQL query engine fits in? I don't think Impala is something that you should write ETL pipelines in. In fact, excuse me, I'm pretty adamant about SQL not being the right way of doing ETL. I think it's really bad at that. It's bad at representing hierarchical records and like all this other stuff that you want in rich data structures. But I think that Impala and low latency SQL query engines in general do have a good role in ETL about doing things like managing the metrics that come off of jobs, being able to quickly look at samples of the data for quality purposes, to quickly compute standard deviation of columns A, B, and C, and things like that. So I think that they do have a role here. Very specifically, I want to call out MapReduce. And the way I like to describe MapReduce is that it's kind of like the assembly language of data processing. Think peek and poke, well, I guess that's not assembly, but you get the idea. And if I had to give it a slogan, the slogan for MapReduce is almost certainly, simple things are hard, but hard things are possible. So it's kind of good, that's kind of the sales pitch for MapReduce. Compared to most things, it is very low level. You operate on a record, and you can tear that record apart, and you can output different types of records. But if I were to sort of walk you through how you join two data sets, given just the MapReduce primitives, it's pretty gross. And you never, ever, ever want to do it for anything other than a weekend learning exercise. At least in Hadoop MapReduce, Java level knowledge and an intermediate Java level knowledge is kind of the price of entry. You really do need it. So in general, if someone were to ask me, I would say use higher level tools when possible. MapReduce is fantastic for compiling down to. And if you're a systems builder, it's a fantastic target language. or target environment. But you don't want to be implementing Java MR jobs for anything of modest complexity or moderate complexity. So by high-level tools, pick your poison. You can, if you like to do ETL and SQL, and that's cool with you, and you can read 9-level deep nested subselects, which my brain pops. I can't do that. You can use things like Hive. If you already have commercial tools like SyncSort or Informatica or Oracle's ODI and things like that, then all of those tools that I just mentioned can push down to MapReduce in various ways and can use the MapReduce framework, and you should use those. If you want to speak Pig, you can speak Pig. But definitely pick a higher level language. And if you want to write Java, and there are cases where you do, where you have 9 billion user-defined functions, or you're doing spatial processing, and like you really need to reach into your grab bag of tricks, then use one of the higher level abstractions on top of MapReduce, like Crunch or Cascading or Scooby or Scalding or any of those guys. But I really want to talk about data organization in HDFS, because even with having all of those things, what we're giving you is a distributed file system, and we're asking you to do data management inside of that. And one thing the relational database world has done is kind of sort of taught us to forget how to manage data in files. We've actually, it's sort of like if you drop me in the woods, I probably can't build a campfire because I'm just too used to turning the little dial and having fire come out on my stove. Not that I use my stove, but if I did, that's what would happen. So going back to using files for data management is actually a challenge for a lot of folks. So what I'm going to do is I'm going to give you my sort of go-to design for sort of doing this. We will wind up using standard file system tricks to make operations atomic. So basically to mimic things like committing data sets and doing batch commits and stuff like that. We'll do fancy things with atomic rename operations inside of the file system. People who have been doing Unix stuff for a long time will recognize these things. And when I want to commit a batch of files in unison or atomically, I'll write them to a directory off to the side, and then I'll rename that directory into place, and I'll do all sorts of things like that. But I really think you need to use a well-defined structure that supports tooling, all of these monitoring processes, and I'll show you what I mean. So again, this is a straw man proposal, but in HDFS, my sort of go-to hierarchy, I start with a file system hierarchy that starts with the intent of the data set. What I'm trying to convey to users, either producers or consumers of a data set, the category of that data set, the application, and maybe that's optional, that uses that data set if it's a private data set, the actual data set name, the equivalent of a table in a relational database, and then I might have data partitioned into separate directories for things like effectively partition pruning or torment indexing. And then at the leaf node, I have actual files. So to give you an idea about what I'm talking about, for public referenceable read-only data sets that are sort of shared across the organization, I'll dump them into data. The fraud group might be the group using that data set, the fraud detection group, hopefully not the group causing fraud. And they might have a transactions data set, like credit card transactions, and then data partitioned by year, month, day, and then sort of at the leaf, we've got here, I'm showing Avro files hanging out at the leaf. On the other hand, you might have data that is private to individual groups. And you might have a group directory and the research group, and they might be training out model number 17, which is like their application name. And they might have training transactions. They might have multiple data sets that go into that model. You can specify a directory for each data set. And again, at the leaf, we've got the actual files that contain the data. So from this, I can actually build tools that do things like quota analysis by data set intent or data set group, or the group that's consuming the data set, and so on and so forth. So I think that having this kind of standard organization is a really good thing. So what I want to do is I want to show you a real customer example, and it's anonymized, and it's actually the union of a couple customers. So this is one customer that I worked with at Cloudera, and this is a real high-level architecture of their data infrastructure. So on the left-hand side, we have producers of data, and these are various services in the data center. They have syslog data, so they basically collect syslog off of every machine for tens of thousands of boxes within the data center. They have application events. These are things like a user logged in or a user added items to a shopping cart. They have clickstream events, which is just everything that happened. You can think of these two as sort of being kind of the same, although the application events are sort of specialized or higher value events. And then they have point of sale data. And actually all of the terminals at the checkout lines, this particular customer has brick and mortar stores. All of their cash register terminals are basically internet terminals. So every item they can scan generates an event, and then a checkout generates an event, and all that other stuff. So in this particular case, the event looks sort of like some headers, which are just key value pairs that have the application ID, just a ID for the application that's unique. The type of event, an epoch timestamp, and I have a whole 1-hour discussion around how you actually manage time in distributed systems and data collection and processing systems. I don't have time for it today. And then the body is just a byte payload of data. And some customers do more structured stuff, some do less. We're using Flume with different channels. So syslog data goes into one channel that is reliable, or sorry, unreliable, but in memory very fast. These channels are fully reliable channels so that we do guaranteed event delivery. And you see that they're going into directories in HDFS, which is something that Flume does natively. And you see that we have syslog data being written to data ops, because it's for the ops group, syslog, and then partitioned by year, month, day. And I think in most cases people do hourly for high volume and stuff like that. And then you might have web core data and web retail data. If you have different sections of the site, you can do binning and partitioning on output. And then for point of sale data, this data was partitioned by country, by region, by store number, by year, month, day. And all that data was being written in. But they also, for various processes, needed data from the web app database, specifically all of the customers who had accounts on the website, including shopping carts and things like that. And they also had an enterprise data warehouse. I think in this case it might have been Teradata or Oracle Exadata or something like that, where they had things like inventory and pending shipping manifests and things like that. These data sets were scooped out and placed into directories on HDFS as well. So this gives you a basic idea of what I'm talking about when I'm talking about bringing all this data together. I also like the idea of structuring data sets in tiers. And I'll get a little bit more into that. But what I mean is structuring data within a hierarchy, basically building a graph of data sets, where you have data sets that are derived from their parent. And the way you derive data set B from data set A is via a data processing pipeline, right? So if you can think of it that way, you think of data as a graph, right, and being generated. So this is actually one step on the larger road to data lineage. And by data lineage, what I mean is that data set foo is the child of data set bar, and so on and so forth. The nice thing about this is that you can actually build idempotent or simple fault and rebuild, maybe not idempotent, but simple fault and rebuild data processing pipelines. In other words, when all hell breaks loose and you realize that you calculated total in the wrong way, you simply wipe out the derived data set, and based on your lineage information, you know how to regenerate it. Now that means that your top rootmost data set must be correct. right? So I'm assuming that we get it into the system in a reliable way. So for instance, I like to think of tier 0 as raw data from source systems. And this would be data coming off your web servers or from syslog or from point of sale terminals. There is no transformation done on this data. Step 1, get it onto disk reliably before you start mucking around with it and throwing data away. Because then, if you don't do that, you have what I like to call the tax audit problem, which is that receipts are very low value. You throw them away all year, and then on April 15th, you get the letter from the IRS that says you're being audited, and all that stuff that was no longer important is now absolutely critical, right? So I like to think of getting data reliably on disk as being your first order of business. And then tier 1 is derived from tier 0. It's cleansed, maybe it's normalized, maybe we correct all the weird capitalization stuff from user to enter data and we normalize it into regions and stuff like that. But beyond that, we might have tier 2, which is aggregated from 1 and might be like summaries of all events in 5-minute windows or 30-minute windows that you use for sort of faster report generation or something like that. This is very, very typical. The important thing is that you never have circular dependencies in your data. Just like in code, circular dependencies in data processing pipelines is a nightmare to unwind. Because then you can't do fault and rebuild. This guy depends on lockstep of that guy, and like they get all weird, and then you have to do record by record fixes and all this other nonsense. So you really want the simple waterfall style data set construction. So here on the left we have a sample tier 0, and on the right we have a tier 1. And we have 3 processes: a web sessionization process, event report aggregation process, and maybe inventory reconciliation, depending on what you're doing. And you can see that web sessionization is taking the core and retail data and joining with the database data from the user information, the user accounts on the website, and maybe it's grouping those by time bucket and doing envelope fall off or session closing, and then building a tier 1 data set. If any time I decide that I don't like the results of this, or that I missed a file and I need to reprocess data, I simply delete that directory and I rerun the process. Everything is completely reproducible the same way in theory. Maven is supposed to give you reproducible Java builds. We can argue about whether or not that's true. But you can see that also your tier 1 might include directories that are destined for export to other systems. So in this case, and working at Cloudera, we wind up using Hadoop as sort of the central data busing system as well, in a lot of ways. What I've shown you is really just kind of the tip of the iceberg, but I think that these techniques make a lot of sense. And that what I'm really trying to do is wrap some reasonable practices and names around, I think, a lot of the things that we do today. And again, like if you talk to folks at SingSort and Informatica, they'll go, yeah, of course, we've been doing that for 30 years, right? So like this is all the infrastructure around, a simple Python script. This is why I think ETL is harder in practice than a lot of people give it credit for. But there is a lot left to do. We really need to build libraries or services and reveal higher level interfaces. And now I'm talking explicitly about the Hadoop stack in general. Like it's pretty low level, there's a lot of sharp edges, and there's a lot of common practices that we, for building processes that we can sort of knock out pretty easily. Data management and lifecycle events, I think, is one of those things that we just don't handle very well. I like to use messaging systems for being able to know when new files are added to data sets and basically instrumenting the data processing infrastructure so that you can attach monitoring systems and other downstream events for that. But there's all kinds of stuff that goes into, for instance, managing evolving schemas, or dealing with upgrades to file formats and all that other stuff. And by lifecycle events, I mean a data set is marked as no longer critical, but in a cold retention cycle or something like that. Instrumenting jobs and services for performance and data quality. MapReduce counters are actually really nice for measuring data quality while you're actually doing processing. So as you're tearing apart records, you count the number of instances of records that look like this and records that look like that, and at the end of the job you have the process data, but you also have a bunch of instrumentation information that you can use for quality. Metadata, and also some more metadata. I think that being able to have metadata about the data sets, schema information, who created it, when it was created, how many partitions it has, how big it is, all of those receipts from the audit problem, like all of that stuff is critical. But also for applications, last deployment time, number of data sets generated by this job, knowing that data set 17 in tier 1 is actually the result of process 4 at version 0.5.9, right? Being able to do that lets you say, oh wow, we found a bug in this Java class, what data is impacted by that? And then you get into what the enterprise guys call impact analysis. But that's the type of stuff that I'm talking about when I talk about metadata. Process or job deployment, service location, where's the job tracker in Hadoop, where's the schema registry, where is the metadata service, things like that. Configuration of jobs. Every place I go into that sort of hand codes ETL processes in Python or Java or whatever has property files for this and command line arguments for that and environment variables for this one really special thing and all that other kind of nonsense. So having a central way to do that. So we looked at this at Cloudera, and I am just so sick of re-implementing this infrastructure at every customer I've ever visited that I made arguments to our CEO and our VP of engineering and a bunch of other people internally, and I said, I really want to build a developer kit that simplifies a lot of, and start knocking out a lot of the stuff that we're talking about. And I don't mean go and build a complete monolithic ETL system to compete with the enterprise vendors, because I think they do what they do very well. What I'm talking about are some of these libraries, some of these missing named parsers and all this other stuff that we implement over and over and over again. So what I did, and I started building a team, and they were lucky enough to give me some folks to be able to do this, was we started to build an open source project that is explicitly geared towards simplifying the process of building data processing applications and systems on top of Hadoop, or on top of what we would consider the platform, which is the Hadoop ecosystem. So for instance, before I get into what we've actually built, this is really for data engineers, by data engineers. So I'm one of the main developers on it, and I've done this for better or worse for a long time. And then there's a bunch of other people inside of Cloudera that are working on this as well. Tom White, who is one of the MapReduce committers, he works on my team. He's the author of Hadoop, the Definitive Guide. So we've got some real Hadoop knowledge behind this particular initiative. We've got some other folks working on it as well. But it's really, kind of by us, for us kind of thing. One of the things that I think when you talk about building a development kit, docs, examples, guides are an absolute must for a minimum viable product, and strong guarantees around deprecation cycles and API compatibility and what's a public interface versus what isn't. We have bulletproofed all of this stuff. So to give you an idea of what we've built, we started with the data module because this seemed like the easiest thing to attack. And what it is simplified data set management in HDFS. So all of that directory naming nonsense that I just told you about, you never have to build that again. The other thing was an application repo or an application management set of APIs for deploying these processing pipelines and then executing them at a later date. And again, it's really just wrapping some best practices around HDFS and things like that. Another thing we're working on is something called morphlines, which is, because we didn't want to call it pipelines, and what it is a library to do, that you can plug into user-defined functions in Hive, or Java MR jobs, or even parts of your application someplace else. It's just a small library that does record filtering, transformation, and pattern extraction from records with like named patterns and things like that.
Is that going to be integrated into Cloudera Manager?
I'll come back to a little bit more about that. That's a good question. So this is just at a very, very high level what the data module winds up looking like. And I'm not going to spend a lot of time on it. I just want to sort of tour you through some of the highlights. So we have this notion of dataset repositories. So here I'm using a file system dataset repository which stores data in HDFS or on your local file system. And what we've done here is configured the file system. We have nice builders for everything if you choose to use them or not. We specify a root directory, and here I'm using /data. That's going to be my repository for data sets. And I create an instance of that. In the second section here, I call repo.create, and I give the data set a name. I call it user events. And I use what's called a dataset descriptor, where I specify a schema. We specify all schemas as Avro. It doesn't necessarily mean the data is stored as Avro, but we use this as an in-memory representation of types and fields and records and all this other stuff. And I've specified a partition strategy. And the partition strategy is what decides by policy how you partition this data set. So what I've done is I've said, there's a user ID field in the user event schema. I want you to do a hash function of this mod 53 so that I bin users over 53 buckets. So it's just hash partitioning. Down here, once that data set is created, I get a writer object, very sort of traditional Java style APIs, not because I think that this is the nicest way to do it, but it's the way that most people already know. So I want this to feel really familiar. We're going to write Avro generic records. You can write POJOs, you can write all sorts of stuff. I open my writer, I use the Avro record builder with the schema, and I say the user ID is 1, the timestamp is whatever I want it to be, build the record, write the record, flush the record, or flush the stream, and then close it. And then on this side, what you will get from this block of code in HDFS or on the local file system is /data, which is our repo, our dataset repository location. You'll get a user events directory, which is the table name. And under the hood, and I'm not showing it here, I'm using the default implementation, there's what's called a metadata provider, which is a plugin interface that you can write your own plugins for. But the default implementation squirrels the metadata for the data set into a hidden directory in HDFS. So you see a schema.avro or Avro schema file, which has the serialized schema, and a descriptor.properties file that tells me all sorts of information about the data set, including user-defined tags and stuff like that. And then, based on the partition strategy, as I was writing data in, the underlying libraries are making the correct calls to create the user ID 0 bin and the user ID 1 bin and writing the right records into the right partitions. We handle all the file creation stuff for you. No, you don't get to pick your file names. Why? Because it's an opaque API. We do all of the dataset management for you. We'll probably open up some of that, but at least in the 0.1 release, which is the stage that we're at, this is what it does for you. This works today. This is an open source system. It is available on GitHub today. You can download it, play with it, and use it. We've been working with the folks at Twitter on a new file format. It's a columnar file format that we're using for Impala called Parquet. So by default, all of this stores data in Avro records, so you can represent arbitrarily complex structures, and it's snappy compressed by default because that's almost always what you want. What we're going to do in the next release, which is May 2nd, we're going to add Avro as Parquet as another option. So you'll be able to specify, I want this data stored in columnar format, so organized by column, or a record-oriented format, organized by record.
So is Parquet going to be like similar to Hive, or is that going to be just really polished?
I'm going to come back to questions and stuff like that, but yeah, I'll come back. So to the contributors, potential and current in this ecosystem, we have a lot of work to do. You know, Hadoop as an ecosystem is not done. That is for sure. There's still way too much scaffolding to have to build these data processing infrastructure and pipelines, excuse me, on top of this platform for people who do this. But I'm roughly out of time for now, although I'll talk your ear off if you let me. But I really want to answer your questions, so we'll do that stuff as well. Make sure you take a look at the CDK. If you go to GitHub, you can fork it today. It's Apache licensed, completely open source, and we are very interested in pull requests. There's lots of guides about contributing and things like that. By all means, send me nasty grams and yell at me on Twitter. If you want to discuss the CDK, we use the CDH, the Cloudera distribution for Hadoop user mailing list. But you'll absolutely never remember that URL, so please just Google it. I've had a lot of fun barking at you guys for 49 minutes and 52 seconds. And if you guys have questions, I want to answer those today. So I know you had a question before. What was your question was?
So,
sorry.
So is CDK going to have some kind of UI integrated into Cloudera Manager?
So the question is, will the CDK have some kind of UI in Cloudera Manager? For those not familiar, Cloudera Manager is our management product that runs on top of Hadoop and manages everything. Today, no. The CDK is a bunch of Java libraries right now. And it doesn't necessarily mean it'll always be that. I definitely want to do things like better C implementations for Avro and stuff like, there's a bunch of stuff that I want to do. And maybe there's a UI component to some of it, but I think we really want all of the stuff in the CDK to be open source. Cloudera Manager is a proprietary product, so we probably wouldn't put it in Cloudera Manager. Hue or one of the other sort of UI web things would be a more likely place for us to put it. But yeah, sorry. And you had a question about?
Just Parquet.
Parquet. So Parquet is a file format. So Hive is like Impala, has no particular file format. There is a columnar file format for Hive today called RC file, which is developed by Facebook. It's good. Parquet is sort of an improvement on that. And if you've ever looked at the Google Dremel paper, the file format that they describe is effectively the Parquet format.
Oh, okay.
So it's repeated records and var-int packing and lots of other fanciness.
Yeah, you talked about on your wish list, or you had a laundry list of things for ETL, process repository, metadata repository, scheduling, process orchestration, service and process instrumentation. And then you talk about Flume, Scoop, Uzi, Impala, the Do Summer, all of those things.
Right.
What about the service and process instrumentation? Is MapReduce counters? You mentioned that. Is that about all that's out there now?
So if I could summarize, the question is, of my laundry list, which is the component or the project or the product that handles the service instrumentation and metric collection and stuff like that? Right. I think that's a hard one because it's orthogonal to the functions of the actual processing pipeline. So and it's a cross-cutting concern, if you want to use that phrase. So like logging and all these other things, you kind of want every process to have this. And the only way I know how to do that is to have some standard set of support classes or infrastructure built into the actual execution framework. So to your point about do MapReduce counters kind of count and fill that void? For MapReduce-based workloads, yeah, I think that's probably good enough for most cases. The MapReduce framework kind of monitors itself and has a lot of metrics there. You get per job metrics. The problem with MapReduce is that there's nothing inherent in MapReduce jobs that tie together related jobs that are part of the same pipeline. So that's on you. So like Uzi may submit job A followed by B followed by C. There's nothing that actually ties those metrics together other than maybe you injecting a property that labels this as pipeline 5 or something. So you need to be really diligent about how you do that. And the best way I know how for sort of hand-coded pipelines like that is to have kind of like a framework for the guts of a job, but that's a hard one. So I tend to use Coda Hales or the Yammer metrics library, has like histogram functions, histogram counters, and like all these other kinds of things to be able to do measurements at the job level. And I might use support classes or delegates or in some certain cases, God help me, abstract parent classes and stuff like that when I feel the need to use inheritance. So there are a bunch of things that I do there, but it kind of depends on the framework and the infrastructure. Did you have a question?
Yeah, so that you showed some processes between your tiers, tier 1, tier 0. How those processes you do in memory?
Oh, so the question is how, in the slide on between tier 0 and tier 1 data sets, the sessionization process and those things, how are they actually implemented? Yeah. In this case, and in the world I live in, most processes are MapReduce jobs, or a workflow of MapReduce jobs. Sure. And those are potentially spilling to disk and doing all sorts of stuff. So they're not strictly in memory, they're logical, but they're these big sort of
like cleansing, normalization, all this MapReduce?
Yeah, so we can do normalization and cleansing, all that kind of stuff in MapReduce jobs, yeah.
And that's like for speaking about that Informatica, so you can plug in directly or you still need a scoopy between like intermediate interface between.
So I'm not sure I understand your question.
So for you need to process set up ETL, like
right.
Say, between Informatica and your Hadoop. It's a directly, or you need a scoopy still?
So most of the data sets that I work with are probably already written to Hadoop by their source systems. Oh. Now, Informatica, and again, my apologies to our friends at SyncSort, but Informatica is the one that I'm just happening a little bit more familiar with. Informatica has two modes with their Hadoop support. One is you can treat HDFS as a source or a target in an Informatica workflow, or it has what's called like a transparent usage mode, where basically what it does is Informatica uses its existing functionality to grab data out of like Oracle or something like that, drop it on Hadoop, run the workflow, and then pull it back out of Hadoop automatically and put it in the right place. And that usually makes sense when the total runtime of the job, it actually makes sense to do that full export process and then full import, run, full export, which it doesn't always make sense to do that. Yeah, so it depends. Yep.
Just as a, can I add?
Yeah.
So I'm with SyncSort, but just to add on what you're talking about, replacing Scoop, we actually have like ComScore uses today to replace Scoop to load their HDFS. So they load about 75 terabytes a day, and they compress it, and then they actually sort it, and then they load it. So we've got a number of customers doing that now.
Okay. Any platform, so Oracle, Digital, SQL?
Yeah, pretty much.
So most when I said like most of the enterprise major ETL players, SyncSort, Informatica, all these guys, they've got all kinds of infrastructure to drastically simplify a lot of the stuff that I'm talking about. So part of this is actually, for those people, this talk I give to those people and say like, what does it look like to actually do ETL or move ETL from, proprietary processing grid of like 8 nodes to a cluster of 800 nodes or something like that. So anybody else? Yeah.
So we use counters within our MapReduce jobs to keep track of a lot of metrics. Mm-hmm. Do you ever find we find that sometimes we want to persist those counters after the fact?
Right.
Is there a slick way that you've heard of people doing that?
Sure. So the question is, when you're using like MapReduce counters for collecting metrics about jobs, and you want to persist those metrics, how do people do that? So in certain versions, there's actually a statistics file that gets generated and dumped into the user history logs directory, which actually has a lot of job counter metrics in it. And it might have all of them. The other thing we used to do before that existed, and that's in CDH version blah, 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 whatever, I'd have to look it up. Or since version, whatever, I have to look it up. The other thing we used to do is there's ultimately something that's actually submitting the job to the job tracker, right? When you submit that job as part of the infrastructure that knows whether that job succeeded or failed, you are inherently blocking or have some callback waiting for that to complete. The job info object you get back from the job tracker allows you to grab the counters and then you can persist them in some way. And if you build like sort of standardized launcher infrastructure, one of the items on my wish list, which turns out I'm going to have to build, you know, because nobody's buying it for me, is one of the things that we'll do, is that we'll kick off a job and then we'll grab the counters and then we'll hand them back to somebody to persist somewhere. Yeah.
As you said, one issue that we see more and more is data management, you know, either on Hadoop or in MySQL or any kind of database. And one specific issue that we see more and more is, you know, data retention. So is it something that you've seen a good option to deal with, or is that something actually that you plan on dealing with a CDK?
Yeah. So the question is, you know, with lots of data management topics, you get into the realm of data retention and how do people do that, and do we plan on doing something like that within the CDK? I think data retention probably means different things to different people. In a lot of cases, there's that policy aspect that says as data gets older, for some definition of older, you might ratchet up the compression, you might down the replication factor, you might do Reed-Solomon coding or something like that, or you might ship it off to some other long-term system. And so I think that if we had centralized scheduling and we had, you know, instrumentation to know when you add new partitions, that scheduler would kick something off that says it's time to see if I need to migrate data off. In Cloudera Manager, we have what we call BDR, which is a business disaster recovery. I actually forget what the acronym stands for. But what it basically does is schedule movement and archival of data sets, usually to another cluster though. Yeah, but which is what a lot of our customers do, because it turns out HDFS is pretty cheap storage for a lot of that stuff. Yeah.
You mentioned Impala for data flow.
Yeah.
How do you dive into that? Do you do it as part of the flow, or do you do it cooperative with that?
So usually, so the question is, I mentioned Impala for data quality measurement or inspection. Do we tie it into the process or do it after the fact? There are two ways I see it being used. One is, excuse me, because all of those data sets in HDFS can be queried directly with Impala because it doesn't have its own file format, you can effectively map a table definition over all of those data sets and query them at any point, right? So what I would do is I would actually create table definitions for every one of those, and the CDK creates those data set definitions by way of its metadata provider plugin. It can be configured to create data table definitions in Hive, in the Hive Metastore, which Impala uses. The idea being that you would build dashboards that maybe run some SQL query every 30 minutes over the last, you know, however much data in each data set, and build like distributions of values and how many missing records are, you know, things like that. So if you have a tool like Impala that can actually query any format, and you have all of your data in HDFS, then you can basically just touch any data set from any ETL pipeline at any time and build dashboards, real-time dashboards on top of that. So usually that's what I would do.
So do you build checks into your flows as well, or do you just assume?
Yeah, I would definitely build checks within the flows themselves as well. And normally you have sort of different levels, right? One is a record is bad, and you might use counters to count that. And if the counter gets above a certain size, you throw an exception, which causes the job to fail, which causes Uzi to retry it or page you or something like that. The other way to do it is, the other level is to monitor the jobs themselves, see if the jobs complete. If the jobs don't complete, again, they fail, they page somebody. I think with the general purpose scheduler, one of the monitoring things that I like, and the thing I like about the standard directory layout, is that for partitioned data sets by time, which with the schema information and some metadata, you have that information, you can say that if the daily directory doesn't show up by 20 minutes after midnight, page somebody, right? Like you can actually build like halting style checks to make sure that everything, that the big machine is working as expected. So I would actually use the directory structure to know not only which directory was missing, but when the timestamp of the last created directory and all that other good stuff. Yep.
About the data lineage issue, like that's basically making sure everything has some sort of audit trail, right?
Yeah, so data lineage has a couple of purposes. One, like I said, is impact analysis. If you discover, so I had a bank, and I can't tell you which one. I had a major bank come to me and say, we just got fined like a couple $100 million by the FCC because our daily total was wrong, and we don't know where. We actually used the wrong field. But so somewhere we used the wrong field.
So I get that.
Yeah.
Writing raw data to tier 0 makes perfect sense.
Yeah.
But I also know that probably a lot of organizations pre-process the data or batch it somehow or lose, like before they even write it to
Yeah.
place. What's the real world pressure that makes someone like build a system like that? Is it just lack of knowledge or lack of storage, or like why do they not write raw data to disk?
That's a great question. So why do people, so by the time most organizations have data in tier 0, it's already been sort of mangled at some level. And why do people do that and stuff like that? There's a few reasons. One is that people new to Hadoop are in this sort of world of saving disk space and stuff. Like they're very geared towards the space and the resource consumption problem. So they're very hesitant to say, what do you mean store all of it? Like they're very skeptical of that. The other is legacy processes, right? Like there's something that kicks the data out and it's already looking like that. So it's a lot of that. And then, people just don't think about it. They go like, well, why keep the thing I don't need? And my answer is always, how do you know you don't need it? You just don't need it now, right? And the same way I don't need my car keys right now, but I'm probably going to drive at some point in my life. So it's easier to see the criticality of things. And quite frankly, the thing that wakes people up is when they drop something that they can't get back. I mean, that's like that bank, like where they kind of went like, hey, like we have no idea how this number came to be, and it's in an Excel spreadsheet, but where that came from is beyond us. That's the kind of thing where like a couple $100 million later, you kind of go, okay, maybe we should keep everything. Like it's that level. That doesn't always hit everybody, and God bless those people, but. I don't really know.
It's a federal regulation. Say for bank, you have to keep 7 years of data.
Yeah, it's a Sarbanes-Oxley.
You don't have any option.
But it's funny because like it's only Sarbanes-Oxley has like this weird clause that says like you only have to keep for 7 years, which you actually generate. So the answer is, well, if I never output it, then I don't have to keep it. Right, so like people play games like that. Like there's all this other nonsense.
And then become an archiving, read-only.
Right.
Say after 3 years it's read-only, and then after 5 years it's archiving. So
yeah, compliance officer turns out actually is a job title. It's just not the one I want.
Exactly.
I heard a story about eBay where they were transforming the logs before they were loading them, and anything that didn't transform properly just got dumped. And there was some fraud case where someone from the inside taught these people how to generate their logs so they would be corrupt.
I've heard all kinds of crazy willy-nilly stuff about data. Any other questions about this stuff? Yeah,
what's the best way to handle small files on HDFS?
What's the best way to handle small files on HDFS? You have a couple of options. One is, and this is where I think policy gets into it, is that write the small files to HDFS and then have a policy connected to a scheduler that wakes up and says, anything smaller than X, I bundle together, right? So you basically just wake up and do compaction. And that seems to work really well. And you can do that, at some off time, or you can do that at some later date, but the data is immediately useful, and then you deal with the sort of fact that you don't want small files later on. Kick the can a little bit down the road.
You mentioned tier 0 and tier 1. How many tiers do you usually get to in practice?
How many tiers do people normally get to in practice? Usually in the public, like enterprise-wide data sets, there's usually like tier 0 and tier 1, and maybe tier 2, like the aggregated data, and the ops group or the data management group will say, for reports that only need 5-minute granularity, please use tier 2, you know. And then you can see that like the fraud group, you know, is tier 3, and then my home personal directory and experiments is tier 4. So I mean, like I've seen stuff when you track full lineage, I've seen 10, 15 tiers deep of derived data. And usually derived data might be a join between, you know, tier 5 and tier 7, and like, you know, like it gets complicated really fast. But I would think in practice, you don't want to go too deep. You know, you want to have as many of those data sets that you use be central, shared, audited, well-known data sets. I think that that's critical. I see people going with jackets on, so what I'm going to do is I'm going to wrap now, and then if people want to sort of chat about individual things, I'm more than happy to do that. Guys, thank you so much. It was a real pleasure for me.